Welcome back, viewers. My name is Christian Obodo. In this video, we are going to focus on Mensuration Volume 2. If that is what you are interested to learn, kindly subscribe to this channel, like and share this video, and also turn on the notification bell so that you'll be notified when I post a new video. Cone, that is what we are going to consider. A cone is a solid shape with curved body, circular base, and a pointed end. As you can see in the diagram below, that is the shape of a cone. And some of the formulas we need to understand are the curved surface area pi RL. The L there is the slant edge, as you can see. Then total surface area by R into bracket R plus L. Another one is the volume of a cone, 1 over 3 pi R square H. Then the slant edge, L, equals to square root of R square plus H square. Now let's see some example. As you can see, we're given a question there and we are asked to calculate the volume, the curved surface area, total surface area, and slant edge. Now let's see the solution there. We are starting with the volume. Remember your formula for volume of a cone, 1 over 3 pi R square H. From the question, our R, which is radius, is given to be 6, and our height is given to be 9. So we impute them, and that will give us what you can see on the board there. So we use our calculator and multiply. That gives us 7,128 over 21. Then when we do that, our answer is equals to 339.43 centimeter cube. The unit is very important. Then curved surface area is the next thing we are solving for. And don't forget, the formula for curved surface area is equals to pi RL. L stands for the slant edge. That is for the slant edge of the cone. So, we are going to first of all find our L. Remember, the formula for the L is square root of R square plus H square. And when we did that, we put in the value of radius and the value of the height, which are 6 and 9. And we look for the square root after adding them, and that gave us 117. Square root of 117 will give us 10.8 centimeter. So that is our slant height or edge. So now we quickly solve for our curved surface area since we have our L. So remember, pi is 22 over 7, radius is 6. Then we put in the value of L. When we do that, our answer will be 1428.24 over 7. And when we divide that, we got 204 centimeter square. The next one we are going to solve for is our total surface area, which our formula is pi R square plus pi RL. Then we brought out pi R, then into bracket R plus L. Remember, our L is the slant height, so the radius is equally known. So we put in our values, and that gave us what you can see on the board. 2220.24 over 7. And when we divided, we got 317.2 centimeters square. Formation of a cone from sector of a circle. You can see from the diagram below, we have the sector and we have the diagram of a cone. A cone can be formed by folding a sector cut from a circle. When the cone is formed, the arc AB, you can see, meets at point X. The arc thus becomes the circular base of the cone. And the original radius OB of the sector, as you can see, also becomes the slant edge OX. You can see it there. The following are the relationship between the sector and new cone form. Base radius R, which is equals to theta capital R over 360. The height of the cone equals to square root of capital R square minus small r square. Let's see example. Now, in this example, we are asked to calculate the base radius, the height of the cone, total surface area, volume of the cone, and also the vertical angle of the cone. So we are starting with the first one, base radius. Remember, our formula for base radius is theta big R over 360. And our big R is the radius, while the theta is the angle given. So we'll multiply 210 by 7 over 360. When we do that, that will give us 40. When we do that, that will give us 4.08 centimeter. Then the second one is the height of the cone. That is the next thing we want to calculate now. And the formula is the square root of big R minus small r. Our big R is the radius. Then the small r is what we just got now. Then the h is equals to 5.69 centimeter. Then the next thing we're solving for is total surface area of the cone. And the formula is there on the board. When we impute our values, our radius 4.08 plus 7, which is our slant height or edge. And when we did that, we got 142 centimeters square. Then the next one is volume. That's what we want to solve for now. And the formula you can see on the board, 1 over 3 pi r square h. And we impute our values. We already know our radius, which is the small r, 4.08, then times our height that we solved for. When we got 5.69, don't forget. And when we impute everything, we got 2083.80 over 21. And the final answer is 99.23 centimeter cube. Then the last but not the least, want to quickly solve for the slant height. And as you can see from the diagram, I'm following the question that was given to us. So that is where we are looking for. I use alpha to represent that. Then I'm bringing out that shape out so that I can actually use SOHCAHTOA to get my alpha. So VAT, I brought it out. So I want to solve for alpha. Remember, our slant height is 7 and our radius is 4.08 as we calculated. So we're going to use SOHCAHTOA since we are concerned with opposite over hypotenuse. And when we did that, we got 0.5829. Alpha is equals to sine inverse 0.5829. So when we look for the sine inverse of that, we got 35.7. But remember, that is 1 alpha we calculated for, but the vertical angle is equals to 2 alpha. So we multiply 35.7 by 2, and that gave us 71 degree approximately. Frustum of a cone and pyramid. If a cone or pyramid standing on a horizontal table is cut through parallel to the table, the top part is a smaller cone or pyramid. The other part is called a frustum. You can see from the diagram, I want to show you the diagram of a frustum as I described earlier on. When you cut a cone, this is what you're going to get. So that is the frustum. The bottom one is what we refer to as the frustum. From the diagram, I hope my diagram is also beautiful. That is the frustum. Let's see an example. The figure below shows a frustum of a cone. Whole bottom and top radii are respectively 12 cm and 8 cm. If the height is 13 cm, we are asked to calculate A. Curved surface area, B. Total surface area, and the C. Volume. Okay, I want to show you the diagram. This is the diagram of the frustum. From the question, we are given the small radius to be 8 cm and the big radius is 12 cm, while the height is 13 cm. That is what you can see in the diagram. What we need to do is to complete the frustum. You can see it there. There we have the big cone and the small cone. We are going to solve for h of the small or smaller cone, and to do that is going to be h over 8 is equals to h plus 13 over 12. Then when we cross multiply, we are solving for h, and the h we are solving for is the height of the smaller cone. So when we cross multiply, and we got this, you can see on the board, 8h plus 8 times 13, that will give us 104 equals to 12h. Then we collect like terms. 104 is equals to 12h minus 8h. So 104 is equals to 12h minus 8h, and that will give us 4h. We divided both sides by 4, and h is equals to 26 centimeter. So that is our h for the smaller cone, as you can see. Then to get the total h of the big cone, we just add the 26 we got plus 13. So that is what I wrote there. When we added 26 plus 13, and that gave us 39 centimeter. So we're going to solve for the slant height of the smaller cone. That is the thing you need to do. We already solved for the height of the smaller cone. To solve for the slant height, we're going to use our Pythagoras theorem to do that. So AC squared equals to AB squared plus BC squared. We already know what our h is, so we are solving for AC squared. So our AB is equals to 26, so we'll say 26 squared, plus our BC, which is 8 centimeter, and that will give us 8 squared. When we added This, it gave us 740, and AC equals to square root of 740, and that will give us 27.2 centimeter. Now we need to solve for the slant height of the bigger cone. We equally make use of our Pythagoras theorem, and when we did that, we got 40.8. So now we go back to our question. Curved surface area. That is what we want to solve for now. Curved surface area, we need to use the area of the bigger cone minus the area of the smaller cone. That is what we need to do here. To do that, the radius of our bigger cone is 12, while the slant height is 40.8. So minus the area of the smaller cone. So the big area gave us 10,771.2, while the smaller one is 4,787.2. Don't forget the over 7. And our answer now is 854.9 centimeter after the subtraction. Then the next one is total surface area. That's what we need to calculate. So to do that, so we're going to add area of circular top plus area of circular bottom plus curved surface area. That's what we did there. When we impute the values, 1,408 over 7 plus 3,168 over 7 plus our curved surface area, and this gave us 201.14 plus 452.57 plus the curved surface area, which is 854.83. Then the final answer is 1,508.6 centimeter square. The next one is volume. So we need to do that. We're going to use the volume of the bigger cone to subtract the volume of the smaller cone. That's what you can see on the board based on the formula. So don't forget. So let's impute the values. 1 times 22 over 7 times our big R is 12, which is the big radius, and our big height is 39. So minus 1 over 3 times 22 over 7. Our small radius is 8, while our small height is 26. And when we did that, that gave us 5,883.43 minus 1,743.24. When we subtract it, our final answer is 4,140.2 centimeter cube. But remember, 1,000 centimeter cube is equals to 1 liter. So to get our final answer, we say 4,140.2 centimeter cube divided by 1,000 to take it to liter, and our final answer is 4.1 liter. Thank you for watching.